Hello, I'm Veronica Laippola from University of Turku NLP Research Group, and I'm going to present here some of our tools that we have developed to make sense of web data. So the internet has a vital role in our lives today. We communicate online, we search for information online, and we spend our free time online. All this creates data, so billions and billions of words. And this data can be used in many ways. For instance, the large language models that we have seen in the news lately, such as the one behind ChatGPT here, they are all developed using masses and masses of web data. So it's pretty much like a gold mine of language data, if you want to think about it like that. But the internet has also downsides to it, or challenges. One of the most important ones is noisiness. So when we use web data, it typically comes as giant automatically collected dumps of documents without any metadata on the contents. So all the documents that you can imagine finding online, ranging from recipes to Wikipedia to machine translated hotel advertisements to technical pages to censored material that you would actually not even want to know exists, they all have an equal status. And in our recent research, we have developed several tools to process web language use so that we would know the contents of the web data sets that we use, and that we could perhaps clean it to make it better useful. So for instance, we have developed toxicity detection for Finnish. Basically, toxic language is any kind of language use that you would not want to have in your data, such as threats or insults or other kind of obscene language use. And our tools are allowed to predict if a document contains toxic language, and then you can take it away from your data set. It's based on machine learning, so it basically just predicts, give a document, and it predicts if it's toxic or not. The problem was that there was no training data for this for Finnish. So to develop a machine learning system, you need training data, so examples of documents and their labels. And preparing this data is pretty time-consuming and expensive. So we were trying to think for ways that we could get the data but not have to work so much for it. And our solution was to try if machine translating the data from English to Finnish would work, and then train the system on these Finnish machine translation texts. And it actually did work. The outcome, so the toxicity detection model and the data is available on GitHub and also on Hugging Face here, as you can see. And you can also test the toxicity detection tool here. So for instance, here, if I put this nasty thing, or give this nasty thing to the model, it will predict that it's toxic with quite a high score. Also, it's pretty sure it's obscene and an insult, which I think makes sense here. Then you see that it's less of a threat and less of an identity attack, etc. So it seems to work pretty nicely. Okay, then another tool that we have developed is something called register identification. So registers are these text categories, such as news reports or reviews or recipes or poems or interviews, different kinds of text categories or genres that you can find online. And normally in these web dumps, we don't know what kind of registers we have in them, but thanks to our tools here, we can find out. This is also based on machine learning. So it's a machine learning model that you give it a text and it will predict to which register category it will belong to. Again, the models and the data sets can be found both at Hugging Face and on GitHub. These tools work for 100 languages. And here you can see some data that we have developed by predicting register category to the documents. So this is something called register OSCAR. So it's based on a pretty famous web crawl data set called OSCAR, to which we have predicted register information. Here you can see some of the languages for which we have data here. So Arabic, Catalan, English, Spanish, Basque, Hindi, Indonesian, Vietnamese, and Chinese. And all this is freely available at this address here. Thank you.